Now that we know what frequency is, let's create our first frequency table. The term simple frequency refers to the number of times a score occurs in the dataset. To calculate simple frequency, we simply count the number of occurrences for each score in the data. To create a frequency table, we begin by creating columns of numbers, called an X column, where we will list all of the values that appear in the dataset, in descending order. Next, we will create a frequency column, where all of the simple frequency values are going to go. The scores in the X column are always arranged in the descending order of magnitude. In other words, the largest score goes on top. The smallest score will be at the bottom. Now, in biological sciences, frequency is cycles per second, and it's measured in hertz, named after Heinrich Hertz. Now, of course, to create a simple frequency distribution, we will need some data. So let's take a poll. I'm asking everyone in the class, how many pets do you have at home? You can count dogs, cats, fish, birds. Add up how many of them you have. Now, for the purposes of this video, I'm going to pretend that I have surveyed 10 people and I've collected some data points. These are the data that I'm going to put into my simple frequency table. So here you can see my data points. I will begin by creating an X column and then using the data points arranged in descending order. The largest value in my data set is a 4, so I will arrange the order descending 4, 3, 2, 1, and the lowest value will be 0. Now, what would we do if one of these values was missing? What if no one had 3 pets at home? The answer is that we would still include the 3 in our X column, but it would have a frequency of 0. In the X column, we want to include the full range of our data, including values that are missing. We will create the F column using the frequency scores. So how many people had 4 pets at home according to our survey? Only 1. How many people had 3 pets? Also 1. Now, by the way, when working by hand, you will find it beneficial to cross out the numbers as you count them. What was the frequency for 2 pets? 3. How about for 1 pet? 2. And the frequency for 0 pets was 3. So now I have created my simple frequency table. You should add these numbers to your pet data table in your notes. Next, I'm going to create another column for the relative frequencies in the data. The relative frequency is a number between 0 and 1 that represents the proportion of time the score occurs in the data set. The term proportion refers to a ratio or division. Therefore, the relative frequency is going to be the frequency divided by n. Because my n equals 10, I will divide each frequency in the X column by 10. For the score of 4 with a frequency of 1, 1 divided by 10 is 0.10. That is the first value of my relative frequency column. The score of 3 also has a frequency of 1, so it also has a relative frequency of 0.10. The frequency of 3 divided by 10 is 0.30. The frequency of 2 divided by 10 is 0.20, and for those who have no pets at home, those 3 people have a relative frequency of 0.30. Now here we have an opportunity to check our work. Because relative frequency is a number between 0 and 1, that is a proportion of the whole, if we add up the relative frequency column, it should always add up to 1. If it doesn't, we've made a mistake. We should go back and check our math. If you have not already, add these numbers to your pets data table in your notes. Now we will add a column for cumulative frequency. The word cumulative means to accumulate. It refers to the frequency of scores at or below a particular score. Let me illustrate cumulative frequency using 2 graphs. In this first graph, scores are plotted with separate lines for each year. We can see how the scores for a particular month compare across the years. In this graph, the scores are plotted using cumulative frequency. The cumulative frequency line always goes from the lower left to the upper right. The steepness of the line gives an indication how much more was being added to the line. The line will never descend because it is cumulative. Once we have added to it, we cannot go back. If nothing more is being added, then the line will flatline. Of course, we can only use cumulative frequency with interval and ratio level data. We cannot accumulate categorical data because it does not have an underlying order. To calculate the cumulative frequency, we will begin with the lowest x value in our data set. So the first cumulative frequency value will be the same as the frequency value for the smallest score in our data. How might we use relative frequency? Perhaps we are selling tickets to a play in 4 weeks. Each week we keep track of the number of tickets that have been sold. Hopefully, at the end, the cumulative frequency adds up to the total number of seats available, and our show has been sold out. Or perhaps we're plotting the number of fatalities that have occurred since the beginning of the war. Each month we tabulate new totals and plot them with an ever-increasing line. When the line is flat, good news, no new fatalities are being added. When the line ascends rapidly, many more people are getting killed. Returning to our pets data, the first cumulative frequency value will be the same as the frequency value for the smallest score in our data. In this case, 0 has a frequency of 2, so that is our first cumulative frequency value. Remember that we are starting at the bottom of the cumulative frequency column this time. Now we begin to accumulate frequencies. For the next cumulative frequency, the answer will be 3 plus the next frequency score, which is 2, for those with only one pet. 3 plus 2 equals 5, so 5 is the cumulative frequency for the score of 1. To the 5, we add 3, the next frequency value, and get a total of 8. 8 plus 1 equals 9. 9 plus 1 equals 10. That is our final cumulative frequency value at the top of the column. Here again, we have an opportunity to check our work. Because the sum of the frequencies always equals the sample size, the top cumulative frequency value will always equal n. Now, add these values to your notes. We are going to add one last column to our table, and that is percentile. A percentile is the percentage of all of the scores in the data that are at or below a certain score. So perhaps you've taken the Scholastic Aptitude Test, and you scored at the 89th percentile. That means 89% of people who took that same test scored the same or below you. Or maybe you got a checkup with your doctor and found out that your weight is in the 23rd percentile. That means 23% of people are thinner than you, and the remaining 77% are heavier than you. We will calculate the percentile by dividing the cumulative frequency by n, then multiplying the result times 100. So let's do that. You can see here that each cumulative frequency score was divided by 10, then multiplied by 100. Beginning at the top of the percentile column, the cumulative frequency of 10 divided by the n of 10 equals 1, times 100 equals the percentile of 100 for the x value of 4. Working down the percentile column, 9 divided by 10 equals 0.90 times 100 equals 90. 8 divided by 10 equals 0.80 times 100 equals 80. 5 divided by 10 times 100 equals 50. 3 divided by 10 times 100 equals 30. Go ahead and complete the table in your notes if any of these numbers are still missing. And now, it's your turn. You have been given a set of data in the notes. See if you can create a frequency table using that data. Be sure to include simple frequency, relative frequency, cumulative frequency, and percentile. And here's a hint. As you are creating your first simple frequency column, you will find it helpful to cross out the numbers as you use them. Before you move along, be sure that your frequency column adds up to a total n of 20. Pause the video now, and when you're done with your frequency table, I will show you the answers. Use this table to check your work. If you made a mistake, try to figure out where you went wrong and correct it. Making mistakes is part of learning.